So there I am, right, minding my own business, contemplating a half-hour binge on social media to see some wrestling bears, wrestling cats, and cats flying, and dolphins arm wrestling freaking boxers. But I quick peek at the comments, right? Somebody, don't you know about Tidal Bulge? Don't I know about Tidal Bulge? This Tidal Bulge, obviously trying to say that the moon does create this massive bulge. Now, first of all, let's not forget something. These two are to scale, okay? This is 30 of these diameters away from here, 9 meters. Right. Don't you know about tidal bulge? That's why it all happens. It is said. Now, I'm sure I know there's a couple of these programs, right? And I don't know how I've not put my foot through the TV when I'm watching them. First of all, do they or do they not say there's 2 arrows and they're both pulling on each other with equal force? They do. But how can they? Straight off the bat, right? I'm going to use my intuition and say that Simon Dan, yesterday when I went, the moon is not creating the tide. Simon Dan, I reckon he's already all over it. But don't forget Simon Dan. If you're going to say things like this, the Earth and the moon have the same gravitational pull, and that the moon creates a little bulge at the front, right? And then all the clever people are thinking, yeah, but there's 2 tides. That doesn't work, does it? Because high tide here, low tide, high tide, low tide, yeah? Well, lo and behold, this moon, by the way, these two are to scale, right? If you measured within a millimeter, 5'5", 18 centimeters, 8.3, 30 centimeters, they're all the same proportions. So what we have is a supermoon pulling and making dust bulge. Now, how is the rear bulge created for the other high tide? You're not going to believe it. Well, you probably do because you've already. So, create a bulge there. But what happens is this little powerhouse, right, even though Earth is 3.6 times bigger, and it's not logical to think that they're both pulling on each other the same, its pull would pull it towards Earth. That is purely common sense, if. But this moon manages to create a bulge here because not only is it pulling the water a little bit, it's actually pulling planet Earth that way, which creates a bulge at the back. And everybody's happy. And if I remember rightly, I think they give you an A and a B and a C. I have never heard, I can't say that now because I have heard the same amount of rubbish in the same short period of time quite often lately. Yeah, I know about tidal bulge, and I can tell you what, it's about common sense. Do I believe it? No, because it's illogical. Don't they say? Now, so, break out in hives. When they free fall to the moon, because that's what they do. They free fall to the moon, don't they? They escape Earth's gravity. No, they don't escape Earth's gravitational pull. They get to a point between Earth and moon that is further away than Earth, like maybe, I don't know, here. That right there is where the attractions of both are dead. They counter each other out. The Earth has a stronger pull than the Moon. When they want to free fall one of the many rockets to the Moon, they have to be this side. They have to be closer to the Moon so that the Moon then attracts the rocket. Otherwise, if it stopped here, if it ran out of fuel here, it would go, it's not going to stay there. That isn't a Lagrange point where all of the gravitational pulls and effects and everything balance everything out and it stays and hovers like the James Webb Space Telescope, Lagrange point 2. This is so illogical, but people don't know how to question it. So yeah, I kind of do know about tidal bulge. I think it's an absurdity. I think it's another insult to the old intelligence over there. But obviously people love it. 5 centimeter diameter moon, 18 centimeter diameter planet Earth. This little dancer is ripping the water off the front and then it's pulling the planet towards it. Enough so that we get another high tide bulge at the back of the planet. Look, lucky we're not on a bus. It'd be empty by now. I might have even gotten rid of the driver. I might have actually jumped out myself by now. The moon is not moving the water on this planet. Somebody said to me, Derby, Western Australia, the tides. There is apparently an 11-meter tide, right? I'm glad I remembered because it would have looked like I was just picking and choosing the comments. Western Australia. It's not the one that we need to look at, but we will. Western Australia. First of all, the good thing about this one is we're kind of a bit closer to the equator, right? Now, the moon, it's orbiting us, but we are spinning faster, all right? So we overtake it and the moon appears in the east and goes out the west. But if we were not moving, go like that. But because we are going faster than it, it appears to be moving east to west. Knowing this, and how far away the moon is, and we're going faster than it is orbiting us, any bulge would constantly be moving, wouldn't it? It's not as if everything's static and it has time to arrange itself. Planet Earth, if it's a planet, is spinning on its axis faster than the moon is orbiting us. I do believe that they say that Earth has to catch up with the moon. What an absurdity. Earth is spinning faster. In fact, for every one orbit the moon does around us, Earth spins 27 times on its axis. For every one that the moon goes around us, we spin 27 times. Now, if you sped that up, that's a good one. 27 times for one. Now, talk to me about bulges. I like it. That's sped up. "27 times for one. 27 times for one orbit. 30 diameters away, that's 9 meters. It's going to go around once, and planet Earth in that once is going to spin 27 times. And planet Earth is catching up to the moon. In that 27 times, this orbits us once, when you speed it up, how is that going to work with the tides? How would they show that in an animation? I'd love to see that. They make it sound so structured. Everybody's had time to organise themselves. Okay, you ready, Moon? Right, start pulling. Slow down, Earth. Hang on. Pull, Moon. It's not like that. 27 times. It orbits us once. That means that the tides are never it's crazy, isn't it? It's not like it's always there. You know, right, pull, 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 pull. No. One spin, 1/27th of its orbit around us. 30 diameters of this away from us. Australia, Perth. Somebody said there are massive tides somewhere in Western Australia. Right? When I got those measurements, 2 search engines, right? And they both came up with the biggest ones. There's a program about the Bay of Fundy tide, right? I'm not lying, that's what came up. I said I'm on the East Coast, we've got Stanage Bay. I've been there fishing. Forget it. When the tide's coming in, 7-something meters. So I'm not saying there are no bigger tides anywhere else. That was not what I was saying. I'm saying that the 4 came up as the highest were up north. It's illogical. So Australia, this bulge, we're moving faster than the moon, but it's orbiting us, but seems to be going that way. So you'd think the bulge would be going that way, right? Now, high tides, you think the bulge, because the water is always coming from east to west, isn't it, the bulge? So we turn into it. Big tides here, and the water would run as it's turning. How on earth is it going to get to there and go in and then go into the facing east? The water is suddenly, even though we're going faster than the moon that is creating the bulge, the water has gone, the bulge is going that way, and then when it gets to there, it's flying into the inlets on the west side of every country. Now, the one that is the craziest is the Bristol Channel, because don't forget this, it's orbiting us, but we are moving faster than the tide maker, right? That means that if it was moving at the same time as us, it's synchronized, what would happen? Are you telling me that there would always be a bulge, one high tide, in the same place all the time? If we were spinning like this, and this thing was following us like this, what happens? You're going to tell me that there would be a bulge in the same place, right? That's what would happen. So there would be no tides, right? But this moon, as we're spinning, it's falling behind us. We're spinning faster than it is orbiting us. Therefore, it looks like it's going that way, right? It's always going to be pulling water from east to west, right? It is. Up here, the Bristol Channel, can you see? Oh, I hope you're close enough. Yeah, right. This is This is important. It's the common sense thing, right? Bristol Channel is that little inlet there, right? It's the bottom of the UK, that's the English Channel, and that is the Bristol Channel. The Bristol Channel is facing west, right? If there was a bulge, it would be coming this side, wouldn't it? Turn into the tidal bulge that the moon is creating. When it comes to the Bristol Channel, it's surrounded by land all the way back. This is the Mediterranean. There's no water coming out of here. There's not many places that water could come from unless it comes from down the South Atlantic and up from the North Sea kind of thing. So when it turns into the magical bulge, right? Why is it that water is gushing into the Bristol Channel? We're not moving into, we're moving away from, and we're moving away from the tidal maker, the moon, faster than it is orbiting us. So it's not like there's 6 hours for the water to catch up because we're moving away from the bulge. If we moved into the bulge, how can you move into a bulge? The water doesn't go over land, does it? It's illogical. The more I look at it, the more I talk about it, the more illogical it is. It's water. You're talking about a gravitational pull. The thing is, the planet is spinning faster than the thing that's orbiting it, creating the gravitational pull. We're moving away from everything that this thing does. We are moving away from it. So fast, in fact, that it's giving the appearance of it moving from east to west. But it's not. It's going around us like that. But we're going so fast, not so fast, but fast enough that even though it's going around us and it's coming from west to east, all of a sudden we're going faster than it, so it's going from east to west. We are always moving away from any Mickey Mouse bulge. The moon pulling the planet. How does it do that? In fact, are you telling me that the planet is always slightly pulled? Because we are spinning faster than it's orbiting us. So is it always pulled? Look, the more you look at this, the crazier it becomes. 19, right, I want to crack this in half an hour. It's ridiculous. So Simon Dan, when you take the Mickey Mouse, mate, make sure you include all these things. The moon doesn't affect the water on this planet. It's about common sense. So it doesn't make any sense. Don't they tell you free falling when they're going to free fall in that way? Don't they say we need to be closer to the moon than we are to Earth so that the effects of the moon pull us in? Don't they say that the moon is moving away from planet Earth 3.8 centimetres every year? How? Don't tell me. The moon is dragging planet Earth with it. Listen, two things, two objects this size, they don't have an equal pull on each other. Planet Earth would wrestle the moon to the ground. It's ridiculous. I can't believe I'm saying it. So just quickly, uh-oh, what's he doing? Oh, did he? He didn't, did he? No. Yeah, he did. Remember, I am lucky. I can have 4, 5, 6 different theories about the same thing in my head at the very same time. And the process of elimination is all done using common sense and logic. I'm not biased. I can have this thought in my head at the very same time as a round planet. You could give me a square planet and a triangular one, and I can easily slot them up there and just go through a process of elimination objectively, which is something you guys cannot do. Now, I'm not saying it's flat. What I am saying is even if it were flat, this moon would not be moving the water like we see it on this planet or on this flat Earth. The reason for that is because none of the smaller bodies of water are moving. And they would move. They would move. If the moon can pull the front of the planet to create a bulge big enough for it to pull Earth into the bulge so that it leaves a back space for the rear bulge, you're telling me it's not going to pull on some of the smaller bodies of water on this planet? The bus would be empty. The driver would be gone. I'm not saying it's flat. I'm not saying it's round. What I am saying is that doesn't happen on a round planet because there is not enough water. They've been submerged. It's obvious that Pyramid Giza was the only thing sticking out of the water at some time. The water was there long enough to make a north, south, east and west face erosion pattern around the top of Pyramid Giza. And then underneath that erosion pattern, it looks like they have all been submerged. They definitely all have the same pattern at the bottom, but not there and not there. Mamma mia. Common sense, folks. There's not enough water on this planet for that to have happened. Asteroid, maybe, but the dust would settle, tsunami would disappear, and wouldn't have been a tidal mark on there. That is prolonged exposure to water. It's an erosion pattern. On this, it's still not explaining why the smaller bodies of water are not shifting even a millimeter. That then brings us to, don't forget, south, 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 south from everywhere leads to Antarctica. But what the flat Earth theory is saying is if it was flat, it's not that you go to Antarctica, I don't like that. It's not that you go to Antarctica when you go south from any of these countries. You are hitting ice. Antarctica, maybe, whatever. But the flat Earth is saying that it is all ice. The ice wall. So you don't know when you go south from certain places that you're not on a flat Earth. That's the kind of science behind it. The pyramids can't happen on a round Earth, that water. The moon is not pulling on any water on this planet. It's illogical because it would pull on the smaller water bodies. It's at the equator. There are tides that don't kind of synchronize with the way the moon is moving around us, and we are spinning on our axis faster than it is orbiting us. So again, every time somewhere like Bristol is due for a high tide, it isn't logical to think that that water is coming from a gravitational pull from the moon that is 30 of these diameters away from us, and we are spinning faster than it's orbiting us. Because there's the channel, and the water is going in that way. Everything screams, There's just no water around. I mean, it doesn't go over. It is illogical. It is illogical. One more time. How would this animation be? 27 times. Once. Bulge, look. I'm not saying it's a flat earth. But the moon, it's not shifting any water. It's not shifting it on what we think is a planet. So why? Well, it's not. It's not going to change, is it? Whether it's flat or round. The moon does not shift the smaller bodies of water, but it can move the whole planet. Now, that right there is Egypt. Tide marks in the centre. We apparently, look, I'm going to check to see. I am going to get some patterns going on this board with these tides. If there's one, Western Australia, that's like 10, 11 meters. Again, it's on the west. So if anything, again, if it's spinning that way, the moon, faster than it, is it logical to think all this water that's obviously going that way suddenly goes into? It isn't logical. If there is a gravitational pull on the water, it doesn't really make that much sense because it's pulling and we're beating it. So if it is like a heartbeat, the tide, totally covers the water in Egypt. I am not religious, but there's always usually some truth in some things that are said. What about Noah's flood? Where did that water come from? I can't believe I'm talking about this stuff, but you have to be objective. A flood. A flood, a flood. The pyramids, it cannot happen. There is not enough water on this planet, if it's a planet, for that to happen and those pyramids to stay submerged that long for that erosion pattern on the top of Giza. Here it works. Here it works. It works. Floods, Noah's flood, pyramids submerged, ice wall, round earth, flat earth. This is not moving the water. There's too many reasons for it not to be. distance, size, equator, not moving any of the water on the smaller water bodies of the planet. I mean, and this, the program that's explaining this, the bulge. Are you kidding me? As you can see in the arrows, both are pulling on each other exactly the same force. No, they're not. The moon moving away from us. 3.8 centimetres every year. Does the moon know it's such a powerhouse? Look. What are we on? Holy smokes! I should want it to be finishing up by now. Right. Dear moon, you don't fool me, you might fool them. 1955. Two, arguably, my two favourites. Light people. Who are they? Those of you who know me will be screaming, Roma and Fitzo! Roma and Fitzo! You're right, Roma and Fitzo! Wonderland in a flash of light. I'm going to read you from about there down and from about there to there. All right, we'll start with the first one. First train out of the station. Oh, Laos Roma. Okay, we have, of the 5 human senses, the scientist regards seeing as the most important. For all his measurements or observations make use of the agency of light to communicate the course of events to his brain. Thus, it is not surprising that the study of light, the great message bearer, should have interested the earliest of the natural philosophers, such as Newton, in their search. Right. Light is something which travels very quickly. This was soon realised when it was found impossible to measure its speed directly with a stopwatch. Well, shiver me timbers. Not a stopwatch. A Danish astronomer named Ole Rømer, 1644 to 1710, showed that light does not travel instantaneously, and he made quite a good estimate of its speed by noting discrepancies in the predicted and actual time at which whose moons became eclipsed. Jupiter's. In 1955, move you forward so that you get a good angle. In 1955, they had decided it was Saturn. Saturn's moons. Now, of course, the screams will come. It's a typo. It's a mistake. No, it's not. Like I always say, it's in the books. They rewrite it as they're going along. When this was written, let's use Saturn. That's what they thought, 1955. Since then, as time has clicked by, 60s, 70s, sometime, they've looked and gone, the rings. Oh, Jupiter's more obvious planets and moons. It was changed to Jupiter. They are rewriting it as they're going along. And you guys aren't listening. Saturn's moons. The second one, guess who? Fitzo. All right. Y'all know what I think about El Fitzo. Yeah? Ashloch. Right, here we go. Although various other astronomical estimates of the speed of light were subsequently made, it was not until the middle of the 19th century that it was found possible to measure it directly on the Earth. Armand Fitzo. Now, did you hear what that said? It said, from Roma, it was not measured up until Fitzo in 1849. Bradley, Wheatstone, what's his name? Arago. How many more? 2, maybe another couple in between Roma and Fitzo. Here it is said that it wasn't possible, right? It was not possible. Oh God, I've got to move it forward 35. I want to get it before 45. Right. Right at the top. Although various other astronomical estimates of the speed of light were subsequently made, it was not until the middle of the 19th century that it was found possible to measure it directly on the Earth. Now, here we go. French professor Armand Fitzo was the first man to do this successfully. He chose 2 high towers or stations a little more than 5 miles apart in his native town of Paris. On the first was placed a bright lamp shining in the direction of the second tower, on which was mounted a mirror. Now, you hear that, a lamp. I have spoken about how stupid this is and said, what kind of light did he use? And people come back at me. It was a something powered light, this, that, and the other. I'm like, what? It's 1849, 30 years before electricity was properly established in Europe. 30 years, a lamp. In 1955, Fitzo was up a tower, another tower about 5 miles, 8 kilometers away. He had a lamp here. And mirror, bounce. Let's listen to the rest of it. He chose 2 towers or stations a little more than 5 miles apart in his native town of Paris. On the first was placed a bright lamp shining in the direction of the second tower, on which was mounted a mirror. This mirror reflected the light directly back to the first station. A toothed wheel was put in the path of the light beam coming from the lamp. A toothed wheel was put. He's looking for a toothed wheel 8 kilometers that way. There's a mirror 8 kilometers over there, and there's a lantern that could be next to him, and he's getting the reflection. 8 kilometers, 5 miles. A lamp. He's looking through the teeth, and you can see the lamp. Basically, 16 kilometers away. It's 10 miles away. It's 10 miles away. The mirror reflected the light directly back to the first station. A tooth wheel was put in the path of the light beam coming from the lamp, so contrived that the light passed through the opening between 2 teeth and was reflected back through the same opening when the wheel was at rest. When the wheel was revolved rapidly enough, the light that returned from the second tower found that a tooth of the wheel had moved into the place of the opening. Thus, no light could then be reflected from the second tower. A lamp. It's 10 miles away. It's not like 5 miles kind of a time 2 thing. It's 10 miles away. It is insane. But you guys love it. You guys love this kind of stuff. Did I tell you a lot about the tidal bulge? The time which the light took to travel from the first station to the second and back was thus the time that it took for a tooth of the wheel to move to the place of the opening. Fitzo. It's incredible. Fitzo could again see the reflected light because a second opening had moved into the line of sight. from a speedometer, he could get the number of revolutions and thus calculate the time that it took for the light to travel between the stations and back. The values obtained for the speed of light indicate that it travels at the high speed of approximately 186,000 miles per second. In fact, it is the fastest moving agency in the universe after NASA. Even so, the distances between the heavenly bodies are so enormous that light often takes years to travel between them. Years. Now, do I know about tidal bulge? I'll tell you what about tidal bulge. We've got a few minutes left. Tidal bulge. It is bullshit. No. Planet Earth and the Moon do not have the same gravitational pulls. The Moon Earth at 3.6 times bigger than the Moon in diameter is not going to get bullied by the Moon like this is. I mean, what the? These are to scale. Look. Listen. There will probably come a time when I won't be able to hire any more buses because of the amount of people I've thrown off of them because of comments like, do you know about the tidal bulge? Can you think for yourself, do you really believe that that is a distance of 30 diameters from that, the sizes to scale, that they're going to have an equal pull on each other? If you believe that, it's purely a lack of common sense. It would nearly be the same. In fact, I don't know which is more stupid now that I think about this. 1, 2, 3, 4, 5, 6, 7, 8, 10, the photos, 11, 12, 13, what a recovery, 40, 50, 60, 70, last 2 or the last 3 with moon buggies. Seriously. It's the things that people are believing that I'll never get over. $2.3, just geezer, 2.3 million 2.5 ton stones. 2.3 million. You know what? 2.3 million 2.5 ton stones. 25,000 Egyptians. Really? You know what? If there were 4424, if there were 2,300,000 Egyptians, 1 2.5 ton stone each, how do you think that would go? I'll tell you how that would go. It wouldn't go, but 25,000 did it. Folks, listen, please stop thinking. All right, buenas noches.